14 grams of potassium nitrate and 40 grams of HCl are mixed. There's the equation. It's balanced. If it's a complicated equation like this, I'll give it to you balanced. If it's a simple one, I might make you balance it. What mass of NO will form? You must account for the limiting reagents. So you will have a question like this on your test. So what is the first thing we need to do? Yeah, we don't want grams, we want moles. So you gotta figure out the moles of each of the reactants. So for iron chloride, all right, we have 56. Peoples. We have 56.8 grams. 1 mole is 126.8. So that gives us 0.448 moles of iron chloride. And then you do the same thing for potassium nitrate. And HCl. Okay. So now we have the moles of each one. What do you do then? Sorry? You got to do something first. How do you figure out the limiting? It's not the one with the least number of moles. Well, it might be, but you don't know right away. That's for percent composition. We did that yesterday. It's a slightly different question. Yes, you divide by the coefficients in the reaction. So for iron chloride, we use 3 moles for 1 mole of potassium nitrate and 4 moles of HCl. So you need to divide by these ratios to figure out what the smallest amount is. So we go, okay, we divide by 3. That gives us 0.149. For potassium nitrate, it has a coefficient of 1, so you're dividing by 1, so that doesn't change anything. And the HCl, you're dividing by 4, because that's the coefficient. And that gives us 0.274. So, which one is limiting? The smallest number, which is potassium nitrate. Okay, so it's not always, in this case it is, but it's not always going to be this number, the smallest moles, right? You have to do this first. So in this case, it's potassium nitrate. Therefore, this is limiting. So that determines how much product we're going to get. Because that one's, when I say limiting, what do I mean? If it's the limiting reagent, what happens to it in the reaction? It all gets used up. Okay, so that's what determines how much product we're going to get. So they're asking us how much NO will form. So now it's just a stoichiometry problem. We have 0.138 moles of potassium nitrate. How many moles of NO are produced for every mole of potassium nitrate? That's the answer. But in the equation, how many moles? What's the mole ratio for these two? It's 1-to-1, right? So that means it won't always be 1-to-1. 1 mole of NO for every 1 mole potassium nitrate. And I want to know how much, so how many grams. Nitrogen oxide weighs 30 grams per mole. So then you just multiply those across and you're going to get 4.14 grams, so 4.2 or whatever you round to. Is that okay? Yes? Okay. Part 2 of the equation. How much of each excess reagent is left over? I'm recording this. I mean, you can take a picture, but I'm just saying I'm recording.
Subtract.
Wow. It shouldn't be minus. Minus is an indication of negative and positive numbers. So you should say subtract, but I understand what you're saying. Go ahead.
Subtract the one we got eliminated from the original number. No. Yes. From the original number of grams. Sorry. Right?
Not quite. You're sort of on the right track, though. What you have to do is you have to say, okay, all of the limiting reagent gets used up, right? So this many moles of potassium nitrate gets used up. So what is the ratio to its other reagents? And then you can figure out how much of those get used up. So we go, all right, iron chloride, we'll look at that one first, FeCl2. We have 0.138 moles of potassium nitrate. That's our limiting reagent. What's the mole ratio of potassium nitrate to iron chloride? Iron 2 chloride, yes. In other words, what are the numbers in front of those chemicals? It's 1 to 3. So for every mole of potassium nitrate, we use 3 moles of iron 2 chloride. Does that make sense? Yes? Oh, excuse me. Okay. They want to know the mass that is used. So then you just use the molar mass of iron chloride, which is, we calculated up here, 126.8. So we go 126.8 grams for every mole of iron chloride means we get 52.5 grams used. That's how many grams of the iron chloride gets used up to react with all of the potassium nitrate. So if I want to know how much is left over, we started with 56.8. We're left with 52.5. You just subtract them. Therefore, 56.8 minus 52.5 is equal to 4.3 grams. That's the amount of iron chloride left, iron 2 chloride left in the beaker or whatever. Okay? And then you do the same for HCl. Do you want me to do it for HCl? I think we should do it for HCl. So, HCl, we'll do in yellow. Same number of moles of potassium nitrate. What's the mole ratio of HCl and potassium nitrate? It's 1 to 4. So 1 mole KNO3 is 4 moles of HCl. And then you do the molar mass of HCl, which is 36.5. which is 20.1 grams used. So then to subtract that from the 40 that were in there. $19.9 grams of HCl left over. I will ask you a question like that on the test. I will ask how much is left over. So it's going to be broken into 3 parts.
These aren't not balanced at all. You don't balance them?
Nope, don't worry about it. You good?
Yeah.
Thank you. Is that okay? And I think, I can't remember exactly what is on the test. You will definitely do how much is formed, count for the limiting. So you have this part, you'll have this part. I can't remember if I asked you to name the equation, like I make it the type of reaction it is, whether it might be a combustion reaction or something. So I can't remember what the first part is. But definitely these 2 parts, okay? So know how to do that. All right? You will also have a titration question. So we'll do this, and then you can just work on whatever for the rest of the day. So this is the last thing we'll do today. 10 mils of calcium hydroxide is titrated with 23.5 mils of 0.156 molar HCl. What's the concentration of CaOH? Do we have a copy down? Okay. People are just staring at me. I guess you don't have to copy it down if it's recorded. Okay. What do we do first? What do you need to do any type of stoichiometry question? Okay. Before you can do anything, you need to know what the reaction is. You need a balanced reaction. So this is a neutralization, right? It's an acid and a base. How do we know it's an acid and a base? Acids start with that, bases end in OH for grade 11 chemistry. And you don't titrations are not always acid bases. Titration just means that you're putting a known concentration into something else to figure it out. You can do redox titrations. So it doesn't have to be an acid base. But I guess in grade 11, we've only done acid base. So. All right, so we have CaOH2 plus HCl. This is a neutralization reaction. What are the products of every single neutralization reaction? A salt and water. So we know we're going to get water. It's a double replacement, essentially, right? This OH gets kicked out by the Cl, or the Ca kicks out the hydrogen, whatever you want to look at it. So our salt is going to be CaCl2, right? Because calcium has a charge of 2. So there's the reaction. Then what do you have to do before you can use it? It's got to be balanced. So balance it. That balanced? Everybody agree with that one? Okay, now it's balanced. Now we can do our thing. So we have 10 mils of calcium hydroxide titrated with 23.5 mils of 0.156 molar HCl. What are we doing? What should we do? Yeah, we can do that. Okay, so this is 0.0235 liters, I guess. Okay. Sorry? We're not doing the dilution, though. We're not diluting it. If I said we were mixing them, 100 mils of this, 100 mils of that, that's a dilution. We're not doing a dilution. All right, we have a beaker with calcium hydroxide in it, and we're dropping in the HCl. Figure out the moles of HCl. Right? That's the first thing you want to do. How much of the titrant did you add? Okay, so moles of HCl. Okay, well, molarity is moles per liter. I'll give you that formula. There you go. So molarity is 0.0156 molar. Moles over the liters, which is 0.0235 liters. So if you multiply those two together, you will get 3.66 times 10 to the minus 4. Is everybody clear with that? Did I do the math right? I don't know. Is that right? Okay. So that's how many 8 moles of HCl we added into here to neutralize it. So what am I going to do now? Has to do with the equation. How many moles of HCl do you need to react with 1 mole of calcium hydroxide? 2, right? 2 moles of this react with 1 mole of that. So figure out the moles of CaOH2. And that's just going to be 3.66 times 10 to the minus 4 moles of HCl. And it's 2 moles of HCl react with 1 mole of CaOH2. So basically divide by 2 and you're going to get 1.833 times 10 to the minus 4. Is everybody clear why we did that? Yes? Okay. So they're asking for the concentration. What's the formula for concentration? Molarity is moles per liter. I know how many moles we have. What's the volume? 10 mils, which is, right? 0.01 liters. If you divide those, you're going to get 0.1833 molar. Sorry? That's what the concentration of calcium hydroxide is at the start. Yeah. Is that clear? You are going to have a question like that on your test. Okay, so you write out the equation, balance it, figure out the moles of whatever it is that you're adding. It's going to be a neutralization reaction. And then figure out the moles of the other substance that you're titrating based on the mole ratio in the equation. And then it's just figure out the concentration moles per liter. All right, I'm going to stop.